Let R be the region bounded by the graphs of the functions. Okay. By the way, don't let that f of x throw you off. That's just y. Remember, function values are y. And this one is y equals 4 minus x. And this one is y is 0, right? So function values are y values. But notice this, dy. They want us to do a dy. It says integrate with respect to y. So that means we got to switch everything. When you're doing with respect to y, what does that mean? Solve for x in each equation. So I got to take this first one, y equals 3x squared, and I got to solve for x. I don't want y, I want x. It's reverse. Whatever you have here, you do the opposite. So this cancels, and we get x squared is y over 3, and then you know how to get rid of that x squared. You root it. And so we get the equation that x is the square root of y over 3. Okay, so we got that one alone. Then we got to make a little table for that thing. So I'm going to say, okay, x, y table. And when we make the table, we're going to plug in, solve for x, plug in for y, the opposite letters, right? So I'm going to plug in 0. Let's just plug in 0, 1, 2, 3. It's probably good enough. We'll see. We'll plug in a 0 right there. Remember, this is x equals the square root of y over 3. Didn't write that very well. X equals the square root. Oh boy, there's not room here. X equals the square root of y over 3. Okay, so plug in a 0. Square root of 0 over 3 is just 0. Plug in a 1. You can here, I'll just go to Desmos. To Desmos. So it's going to be the square root of 1 over 3. What do we get? 0.5. So I just rounded to 0.6 just for graphing purposes. So that's going to be 0.6. Plug in a 2 over 3. Just use Desmos. Come back up here. 2 over 3 is 0.8. Good enough, 0.8. And plug in a 3. You can tell 3 over 3 is going to be 1, right? Square root of 1 is 1. So 1. All right, so we got that. And now let's do a line of separation. Let's do the other equation. So I'm going to take the other equation, and I'm going to get this one right here. So I'm going to say y equals 4 minus x. But again, I want to solve for x, so move that over. So we get y minus 4 is minus x. And then you got to divide through by -1 to get rid of that negative sign. So 2 negatives make positive. This is negative y plus 4, right? Because 2 negatives make a positive. 4 over 1 is just 4. So there we go. We got x alone. Make a little xy table for that. And boom. Whoop, that's very nice. Boom, boom, boom. Again, we're plugging in for y, 0, 1, 2, 3 should be plenty. And we're talking about x equaling minus y plus 4, as it says right there. So if I plug in, oh, this is so weird for x and y. So I plug in a y that's minus y plus 4. If I plug in 0, put in a 0, x is just 4. Put in a 1, minus 1 plus 4 is 3. Put in a 2, minus 2 plus 4 is 2. Put in a 3, minus 3 plus 4 is 1. That was easy. So there we have some values. So now we can begin to do a little graph, and that's what we need to do. Got to graph this thing. Okay. So I'm going to go 1, 2, 3, 4. I'm going to go 1, 2, 3, 4. All right, let's put some points on the graph. So 0, 0 for this one, 0, 0, and then 0.61 over 0.6 of 1, about, I don't know, about right there. 0.82, about right there, and over 1 up 3. So right there. So this one's going like that. And no, it makes sense. It's an x squared graph, huh? So it goes up like that. Now the other one, the red one, we're going to start with his points. So if you can see him, He's over there at 4, 0. So that'd be 4, 0 right here. And 3, 1 over 3 up 1. And then over 2 up 2 right here. And over 1 up 3. Boom. Look at that. They hit right there. That one's just a straight line, isn't it? Like that. Yeah, because that's just linear equation, straight line. So there's where they hit. We found the intersection point. That's nice. And the other one is, what's the green one? Oh, y equals 0. What is that? That's just at a y height of 0. So that's just going to be right here, right? That's y equals 0. Okay, this blue one is at this one right here is x is the square root of y over 3. And the red one is x equals, oops, that's not very neat. X equals minus y plus 4. Okay. And so now we want the area between them, area in the middle. This area here captured by those guys right there. So, and we're going to integrate it though, dy. So we're going vertical. We're going up, dy, up the y-axis. The y-axis is the x, as you know. So we're doing dy. So we're going to go like this. Boom, 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 boom. Rectangles going up. So we're going to integrate from the bottom to the top because it's dy, going vertical. And each of these rectangles, say like this rectangle right here, is going to have an area. The height of it, the height is just dy. And the width of each of these rectangles from there to there, from here to here, is the right point minus the left point. That's how we, oops, kind of scribbly. The right point minus left. So I'm going to go right minus left dy because that's the width and that's the height. The height is dy. The area of a rectangle is width times height, right? So what is the right function? The x value for the right function is minus y plus 4 minus the x value for the left function is square root of y over 3. And of course, we're going to have our dy. We're going to integrate from the bottom to top. What's the bottom? It starts down here at a height of 0. What's the top? It hits up here at a height of 3. So there it is. It's the integral from 0 to 3 of that. Is that what they got? 0 to 3 of 4 minus y minus root y over 3. Yeah, 4 minus y or y minus y plus 4, same thing, minus root of y over 3. And so there we go. Now, if we kind of got lucky that they intersected right there. If they hadn't naturally intersected, we would have had to set them equal to 0. So you might have one where you've got to find the intersection. So let me just show that in case you run into one where you can't find the intersection point. So let's do that. So how do you find the intersection point? You set them equal. You set this equal to that. You want them to equal each other. So the square root of y over 3 is minus y plus 4, right? This x value equals that x value. That's where they intersect. How are you going to solve that? Well, you're going to square both sides to get rid of that root. That's a little tricky. This is not an easy one. So that's y over 3. And then what's this side? You're going to need to write 2 of those. The second power means 2 of those. So we get y over 3. This is just, I'm going to run out of room here. I'll do it quickly. Then you go boom, boom, y squared minus 4y, boom, boom, minus 4y plus 16. And so that's y over 3 is y squared minus 8y plus 16. This is not easy. Multiply through by 3 to get rid of that fraction. So y is 3y squared minus 24y plus 48. And then subtract y from both sides. 0 equals 3y squared minus, yeah, I did not expect this to be quite so long. Let me help here. One more time. I am subtracting y, 1y that is. Come on. 1y, right? That cancels this out. This will make this minus 25y plus 48. And then after all that, you're going to need to go and do the quad, right? Negative b plus or minus square root of b squared minus 4ac all over 2a. This is your a. This is your B, this is your C. Plug those in and you will get that y equals 3 value that we just naturally stumbled upon. So that's kind of a pain. To find the intersection, you got to set the two functions equal and you got to solve, and that's a pain. We naturally just said you could probably just find it naturally by making tables, right? I just made the tables up here and we just happened to find it, right? It was over 1 up 3. Yeah, over 1 up 3, over 1 up 3. That just appeared in both tables, didn't it? So boom, there was the intersection over 1 up 3. X is 1, y is 3. Height of 3 is the top of our integration, and the bottom is down here. So we know our integration went from 0 all the way up to the top of 3. It's from 0 to 3. But if you didn't naturally find that, you would have to set the two equations equal, find this, like solve, square both sides, FOIL that all out, get rid of the fraction, get rid of the y. It's a pain. Then do the quadratic formula, do all that work, dot, 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 and you'd find y is 3. You'd find some other crazy answer as well, but y equals 3 is what you would need. There we go. Here's the actual graphs on Desmos. You want to see them? We got them pretty much right. See, there's the y equals 0. There's the straight line. There's the curve. We integrated from here up to there. And see, they intersect up at 3 over 1 up 3. It's all correct. And there we go.